So we had to do more difficult types of namings, TK. So that is what we're going to start with. I'm just going to do this quickly. The ones that we were doing simple namings, just straight chains. No multiple functional groups, and I said they weren't multiple functional groups. Just simple functional groups, one single functional group. So first one, I'm going to pick this one, and we're going to try and name this one. So that's 3 carbon atoms. So the name would start with prop. And it's an alcohol, so it should end with all. The middle part is AN or EN. It's a double bond, so that's definitely an EN. And you've got 2 alcohols, so that's a diol. Okay, you've got 2 of them. And now you have to give the position of the double bond as well as the alcohol group. So you're going to count from the side which gives the smaller number. So we're going to count from this side. The OH is at carbon number 1, and one of them is at carbon number 2. So this is 1. This one is going to be 2. This one is going to be 3. So you got 1 at position 1. One of them is at position number 2. So those are your 2 alcohol groups, and your double bond is at position number. It's at position number 2 as well. So the double bond is at position number 2 as well. So that's the name of this particular molecule. Okay, so it's an alcohol, unsaturated, 3 carbon atoms, 2 alcohols, diol, both positions given, double bond position given. Okay, that's the first one. This one is 4 carbon atoms, so that's bute. It's a carboxylic acid, so it's an oic acid. Again, this one is unsaturated, so instead of AN, it's going to be EN. And remember, for carboxylic acid, this one is always number 1. So you're going to count from this side. So the double bond is at carbon number 2. So it's bute 2 in oic acid. So that's the name of the molecule. So then you've got this one over here. That's an aldehyde. So that's 1, 2, 3, 4, 5 carbon atoms. So 5 carbon atoms is going to be pent. It's an aldehyde, so there's going to be al at the end. En in the middle instead of an, because there are 2 double bonds, so that means it's diene. Okay, you've got 2 double bonds in the molecule. There's one over here and there's one over here, 2 double bonds. The aldehyde is always carbon number 1. So 1 double bond is at 2, and the other one is at 4. So it's going to be at 2 and 4. So you got 2 double bonds, and it's an aldehyde. Okay, you don't give the position of the aldehyde because it's always at the end. And then you've got a ketone, 5 carbon atoms, so that's pent. ONE at the end. It's a double bond as well, so that's EN. The ketone group is at position number 2, so that's 2-on. Or uske alawa ke, that's there's a double bond at position number 3, so it's 3 in and 2-on. So that's the name of this molecule. So so we've done the naming, the simple ones. Okay, we're going to move towards. Is this one clear? Okay, Abhinash, Hania, is this clear?
Yes, sir.
Okay, so let's move to the more difficult ones. Let's talk about branching now. So more complicated, multiple functional groups, and they're going to be branched as well. Now, remember, one rule about naming is that your naming system kind of fails after a certain point. Like if a molecule becomes really complicated, you can't really name it. It's like, I mean, instead you start giving them generic names. Like ethanoic acid is also known as acetic acid. So your nomenclature doesn't really work for very complicated molecules. The nomenclature works, the rules work if the molecule is simple enough. Uh, but as things get more complicated, then you just stop using the nomenclature because it's not going to work properly. So multiple functional groups, branches. So we're going to start naming them now. So the name is going to be in three parts. One is your main, it's going to be called your main chain. You're going to have a main chain. Then you're going to have your branches and the position of those branches. Okay, so the molecule would be named in three parts: position, branches, and main chain. You're going to start off with the main chain. What is the main chain? The main chain has lots of rules, but the main I'm going to keep things simple because they're not going to ask you very complicated things. And there are lots of rules for naming, so you can't really even remember all the rules. The basic rules are that it's the longest continuous carbon atom chain. And it should have the maximum constituent groups. Like anything, any group that's important, any functional group, it should be on the main chain. So it's the longest continuous carbon atom chain, which should have the maximum constituent groups, whether they're double bonds or OH groups. Most of the things must be attached to the main chain. For example, I've got a molecule and it's got these branches, and there's an OH attached and an H attached to an H attached over here. These are all hydrogen atoms. You've got hydrogen atoms over here. There's a Cl, a Br, and the rest is all H atoms. So I want to figure out the longest possible chain. Now there are lots of options. Remember it's the longest continuous chain. It doesn't mean it should be a straight chain. It could go zigzag. It could be a bent chain, but it has to be a continuous chain. Now, one option is going with this one, right? That's like 6 carbon atoms. That's the longest possible continuous carbon atom chain. But that's not the only condition. It should have the maximum constituent groups as well. I mean, anything that's important must be on the main chain. But over here, if you look, the double bond is not in the main chain. The OH groups are not in the main chain. So a better main chain over here would be this one. Okay, it's a continuous carbon atom chain, but this one has the maximum groups attached on it. The bromines, the chlorines are on it. The double bond is on it. The OH is on it as well. Okay, is this point clear? What's the main chain? Clear? Yes or no?
Yes.
Okay, and I mean, you want pretty much everything, and it even if there's a compromise, then you can let go of the longest. I mean, it shouldn't necessarily be the longest chain as well. Just a second, my mouse. It shouldn't necessarily be the longest chain. It's way more important to have the maximum number of groups on the main chain. So that's the first rule. So then the issue is, how do you name the main chain? Just 1 second, let me message. So now another very important thing is we can leave this. So another very important thing is how do you name the main chain? The prefix is the number of carbon atoms. So it's the same way. I mean, whatever you just did, it's going to be done in exactly the same way. So the prefix is your number of carbon atoms. Now the issue is who decides the suffix? If you've got multiple functional groups, then how is the suffix decided? The suffix is decided, or what you're going to call the main chain, whether it's going to be an alcohol or a carboxylic acid or an aldehyde or a ketone. So suffix is decided. I mean, the ending name would be decided by the highest precedence group. Which basically means the most important group that's part of the main chain is going to be deciding what you're going to call it. Okay, so that's the one that's going to decide it. So there's a precedence now. And what is the precedence? Okay, not all groups are equally important. Remember, I'm dealing with molecules that have multiple functional groups now. So the rule is I'm going to write down the precedence of these groups. And let me add some other groups to this one, just a second. This one just add one alcohol. Let me add an aldehyde as well over here. Instead of the Br, I'm going to add an aldehyde just to have multiple functional groups. Okay, so this one has an aldehyde as well as an alcohol. So we're going to start writing the precedence of these groups. And the first one, the most important one, is carboxylic acid. So remember, if a molecule has a carboxylic acid in it, the main chain is going to be called a carboxylic acid. I mean, you're going to call it a propanoic acid or methanoic acid or butanoic acid or whatever. Even if there's an alcohol, even if there's anything else, you're going to call it a carboxylic acid. That's the first thing. Followed by nitriles. That's number 2. Nitriles are the ones with CN in there. Number 3 is going to be aldehydes. I'm just going to do the ones which are important. Number 4 is ketones. Number 5, after ketones, you've got alcohols. And then you have your last final one is amines. I mean, you've got all the other organic compounds as well, but we're going to ignore all of them. We're just going to learn the precedence of these groups. Even nitriles are not important. You don't really study nitriles as a functional group in organic chemistry. Just 1 or 2 places where nitriles come in. So that's your precedence. And let me explain what precedence is. So, and I'm going to the main chain would be called an oic acid. If there's a carboxylic acid, it's going to be called a nitrile. If it's an aldehyde, it's going to be al. And remember, it always remains a suffix. So a molecule can have multiple suffixes as well. Ketone is going to be called an one, and it's always going to be a part of the suffix. An alcohol would be an all, but if it's a branch, then you call it a hydroxy. And amines are going to be called amines, that's it. And again, if it's a branch, you're going to start calling it amino. Anyways,
Sir, what about ethers? What if there's an ether in the middle of the chain somewhere?
no, we're not gonna do ethers because not in Cambridge CIE. Okay, so
Okay.
we're not going to talk about esters. We're not going to talk about ethers as well, because the nomenclature for esters and for quite an extent for ethers as well, it doesn't really work for them. I mean, you give them generic names, then you don't. So the nomenclature pretty much fails in those cases, especially if the complexity increases just a tiny bit. You stop using the nomenclature altogether. Anyways, I'm going to explain the precedence first. So forget the branches at the moment. Let's understand precedence. I've got a carboxylic acid. And this carboxylic acid also has an alcohol. It's also got an OH group. And another thing about numbering is numbering or position is done to give the smallest number to the highest precedence group. You don't care about the numbers of the other groups. You just care about the highest precedence groups. So numbering is done to give smaller number to the highest precedence group. And so multiple function groups. I've got multiple function groups. Some are more important than the other ones. So this one is a carboxylic acid. Plus it's also an alcohol. So anyways, how would you name this? It's got 3 carbon atoms, so that's prop. Now tell me, what do I call it? It's saturated, so I'm going to call it AN. What is the suffix that I'm going to give it? Am I going to call it a propanoic acid or
propanoic acid?
Okay, so I'm going to call it
3-hydroxypropanoic acid.
Okay, exactly. So I'm going to call it a propanoic acid. Remember, this has higher precedence. Okay, in the whole precedence group, sorry, the precedence of these functional groups, carboxylic acid has a higher precedence. So this one is propanoic acid. What do I do with the OH then? The OH will then be considered a branch, and you write the branches before that. And I told you that if you don't call it an alcohol, then the OH will be considered a branch, and it would be called hydroxy. So it's going to be hydroxy. Numbering is done to give the smaller number to the highest precedence group, which in this case is this one. It's carboxylic acid over here. So I'm going to give it number 1. This would be number 2, and this one would be number 3. So the hydroxy is at number 3. Okay, so remember that alcohols are going to turn into they're going to turn into a branch, and you're going to start calling them hydroxy groups. So here's another one with multiple functional groups. Is this one clear? Everyone, is this clear?
Yes, sir.
Yes, sir.
Okay. So let's do another one. I've got an alcohol. There's another alcohol, and I've got an amine. Okay, these are all H atoms. So this one, again, it's just a straight chain. 4 carbon atoms, so that's butanol or amine. I mean, which one is more important? It's alcohols that are more important, right? So the suffix, the name is going to be end with all. It's saturated. It's going to end with all because it's an alcohol. The OH groups have a higher importance compared to the amine. So you're going to call it butanol, and there are 2 of them. So you're going to call them diol. And you're going to count from the side that gives the lower number to the higher precedence group. So the OH, they need to be given a lower number. So this one would be 1, 2, this is 3, and this is 4. So this one would be 1, 2 diol. And this NH2 would now be known as your amino group, and that would be considered a branch. Okay, remember we wrote this that if you're not naming it after amines, then amine is considered a branch. And one second. Just 1 second. Anyway, so now my mouse is stuck. Just a second. I say it's a branch. So you'll call it an amino. So this one would be called amino, and the position of the amino is on the fourth one. So it's going to be 4-amino, butane 1,2-diol. Okay, is this also clear?
Yes, sir.
There's an issue with aldehydes and ketones, and to an extent with nitriles as well. We're not going to cover nitriles. They're not important. Let's take to aldehydes and ketones. There's an issue with aldehydes and ketones, and that issue is that they always remain a suffix. I mean, they don't become a branch in the first place. So if a molecule has a carboxylic acid and a ketone as well, so it's a 5-carbon atom molecule, it's a carboxylic acid, plus there's a ketone group as well. Okay, let's change the position of the ketone group. So it's a ketone as well, and there are 3 hydrogens with this. They've got 2 hydrogens with this, and there would be 2 hydrogens with this as well. Now this one is 5-carbon atom, so it's going to be pent. And it's going to be AN, indicating that it's going to be saturated. It's going to be oic acid. Why? Because the carboxylic acid functional group is more important. So you're going to give it, I mean, you're going to call the molecule a pentanoic acid molecule because this is more important. And all the numbering would be done from this side. This one would be given the smaller number. So it's going to be 1, 2, 3, and 4. But you've got a ketone at number 4. So ketone is on, the suffix is on. That suffix would still remain. I mean, the ketone never changes. So the molecule is going to have 2 suffixes. And the ketone is at position number 4. So it's going to be an on followed by, it's going to be an on followed by the oic acid. So is this clear? That your aldehydes and ketones, they always remain a suffix. Okay, even if there's a higher precedence, so the molecule will have multiple suffix now. The final suffix would be the most important ones. If it's an aldehyde or a ketone, you're just going to add that suffix before that. So is this also clear? Yes or no? Is this clear?
Yes, sir.
So that's about multiple functional groups. TK. So remember the precedence factor. TK. How are you going to deal with that? The other thing is we're going to move towards branches now. We did some branches over here, so we're going to start moving towards branches now. Remember the naming is the same. It's going to be a main chain. Then you'll have your branches. We didn't talk much about the branches. TK, my mouse has stopped working again. Just a second. So is this one. Where were the branches? I say everything would be a branch. Zaib, I'm going to do that. Okay? Double bonds with multiple functional groups. I say anyways, these one, the one with branches. Okay? So you'll have a carbon branch that's known as an alkyl branch. So for example, if you've got a 3-carbon atom alkyl branch, that would be known as, I mean, if it's a 1-carbon atom alkyl branch, it's going to be known as methyl. That's just as 1 carbon atom, it's going to be ethyl if it's got 2 carbon atoms and so on. And you're going to give the position. Now I did talk about the position, that the position is decided by the highest precedence group. So let's do a more complicated molecule. The only thing is now I'm going to have these alkyl branches. And another thing is, the these chlorine, bromines, and iodines would also be called branches, and they would be referred to as chloro, etc., bromo, iodo. So here's a 4-carbon atom molecule. It's an aldehyde. Plus, it's an alcohol. As a plus, I've got another carbon chain. There's a double bond here. Okay, let's add something else. There are 2 Cls over here, a Cl and a Br. And 2 hydrogens with this, 3 hydrogens with this, and an H with this. Now, the first thing is the longest carbon atom chain. I'm going to use this one. This is the one with the highest number of groups attached. So I'm going to take that, and that's bute. That's my main chain. I'm going to decide the main chain first. And who am I going to name the main chain after? You've got an alcohol, you've got chlorines, double bonds. Aldehydes have a much higher precedence. So I'm going to call it an aldehyde. And instead of En, I'm going to call it En. I'm going to call it En because it's got a double bond. Plus, it's an aldehyde. And remember, the position, the smaller number has to be given to the aldehyde. So we're going to start counting from this side. I'm going to start counting from that side. So that's 1. This one is 2. This one is 3. And this one over here is number 4. So the double bond is at position number 3. So I'm going to call it 3-ene. For the aldehyde, I don't have to give the position. It's always number 1. So if it's not number 1, then I mean, you can call it 1. You can write the position 1 over here, but that's not required. So that's your main chain. Now I'm going to start adding the branches to this. So there are lots of branches. There's a Cl branch, there's a Br branch, there's an OH branch, and there's a CH2, CH3 branch. So I've got an ethyl branch. Okay, that's 2 carbon atoms, so it's ethyl. I've got a hydroxy. Remember, when OH becomes a branch, it's a hydroxy branch. I've got a bromo branch, and I've got a chloro branch. So I've got plenty of branches. I'm going to start writing those branches in front of them. Okay, so there are plenty of branches. So we're going to start writing those branches. One thing about branches, when you're writing branches, is they should be alphabetical. Okay, they have to be in alphabetical order, so just a small point. Which one is going to come first? I think bromo would be first. And after that, there's going to be chloro. After that, it's going to be ethyl. Then it's going to be your hydroxy branch. So these are all my branches. And I'm going to give the position of these branches one by one. Bromine is at position number 4. Chlorine is at position number 4 as well. So it's 4 bromo, 4 chloro. Ethyl is at position number 2. So that's your ethyl, and your hydroxy is at position number, it's at position number 3. So it's 4 bromo, 4 chloro, 2 ethyl, 3 hydroxy. Bute, 3 ene, and al, that's an aldehyde. So that's the name of the molecule. Okay, is this example clear? Is this clear? Yes or no? Is this clear? Hania? Mariam, is this clear? Alicia?
Yes, sir.
Yes, sir.
So let's do some more. You're not going to get this complicated molecule. Most of the molecules that you're going to get are going to be kind of simple. So let's try another one. TK, let's do something that's slightly more simpler. So here's a carboxylic acid. And there's a and an OH. So we're going to try and name this molecule. Kind of simple, it's just 3 carbon atoms. That's the main chain. Maximum groups attached, so that's prop. And it's no double bond, so AN. And it's got a carboxylic acid. That's the highest precedence group, so it's going to be propanoic acid. You're going to count your, this one would be given the smaller number. So this is 1, this is 2, and this one is 3. Then it's an aldehyde as well. At number 3, position number 3. So remember, aldehyde is al and it always remains a suffix. So I'm going to move the propanoic acid a bit further, and I'm going to add another suffix, which is going to be in this case al. This time I would have to write the position because it's at position number 3. So it's got 2 suffixes now. It's an al as well as an oic acid. So after that, what do you have after that? You've got the branches. Just a second. So now after that, we're done with the aldehyde. OH is hydroxy and CH3 is methyl. So alphabetically speaking, hydroxy would be written first, and methyl would be written after that. And both positions are number 2. So it's 2 hydroxy and 2 methyl. So that's the name of this molecule. The molecule, so it's a propanoic acid with an aldehyde, and you've got 2 branches as well. So is this clear?
Yes, sir.
Okay, and we can try writing the skeletal formula and the structural formula for this. For example, the skeletal formula for this would be, I mean, we're just practicing the skeletal formula. So it's 3 carbon atoms, 1, 2, 3 carbon atoms. So that's 3 carbon atoms in a row. Middle one, there's another carbon atom. So there's another carbon atom. The last one is carboxylic acid. So double bond O, which the end one over here is an aldehyde. So that's double bond O. And then you've got an OH group on the middle carbon atom, which is over here. So that's the skeletal formula of the molecule. The condensed version would be aldehyde is always written as CHO. You can remember, instead of COH, it's written as CHO, this side over here. And you've got the middle carbon atom. That's got 2 branches. It's an OH at the top and a CH3 at the bottom. So 2 things. And the end over here, that's a carboxylic acid. That's COONH. Okay, so we've written both versions of this molecule. Then we've got, so let's try and do some questions. On naming, just a second, worksheet. So let's try and name this one. So this one over here is the longest continuous carbon atom chain. That's going to be this chain over here. And that's 1, 2, 3, 4, 5, 6. So that's an alkane. 6 carbon atoms, that's hexane. Okay, so that's no complications, just an alkane with a branch that's coming out from the, it should be, because there's no other higher precedence group. So you have to give that the smaller number. So it's going to be 1, 2, and 3. It's on the third one. So it's going to be 3, methyl, and hexane. So that's 1. So over here, I'm being asked to find, I mean, this one is slightly more difficult. Like if you're given the name, you have to write the structure of the molecule. So you start off with the main chain. That's a hexane. So that's 6 carbon atoms. It's an alkane. And 2,2,4 trimethyl. That means trimethyl means there are 3 methyls. Methyl means 1 carbon atom. And 2 of them are at position number 2. So there's 1 carbon atom branch over here and one carbon atom branch over here. And another one is at position number 4. So this one over here is a methyl at the second, a methyl on the second, and a methyl on the 4th one. So what about this one? This is but-1-ene. So but is 4 carbon atoms. 1-ene means the double bond is on the first one. And on the third one, there's a methyl. So that's going to be 1 carbon atom. And you can add in the hydrogens yourself. So then we can do this one. What would you call this one? The main chain has to be the one with the most constituent groups, the most things on it. So we're going to take this one. I mean, they've already numbered it as well. So I mean, you had a better option, but for the longest chain, but you don't go for the longest chain. The longest chain, you're going to look for the longest possible chain with the most groups attached. So this is the only one that's possible, because if I go with this chain, then the double bond, one of the double bond is not on the main chain. So we're going to go with this thing. And that's but, and it's ene, and it's diene, because there are 2 of them. One is at position number 1, the other one is at position number 3. And you've got a 2 carbon atom branch, that's your ethyl. And it's at position number 2. Is this also clear?
Yes.
Yes, sir. Sir, the double bond must always be in the main branch, main chain.
But the whole point is that the main chain, it should be the longest possible chain, but with the maximum groups attached. I mean, all the double bonds, the OH groups, the carboxylic acid, aldehydes, keto, they must all be part of the main chain. Okay.
All right, sir.
So this one, 2-iodo-3-methyl pentane. So you start off with pentane, 5 carbon atoms. An alkane, so that means ane means no double bonds. Then you've got a methyl on the third one. Methyl is 1 carbon atom. And you've got iodine on the second one, so that's an iodine atom. And you can add in all the hydrogens. So that's a diol, 4 carbon atoms. But AN, because it's saturated, all, plus it's a diol because 2 alcohols, and the positions are 1 and 2, so it's going to be butane 1, 2 diol. This one is what? It's a ketone. So but. What's the position of the ketone? That's on the second one. And you have a branch of methyl, that's on the third one. So this one is butane 2-ol. And how many are left? So let's try and name this one. Let's do this one. Okay, let's have this one. So 1, 2, 3, 4, 5, 6, 7. I mean, that's going to be 7 carbon atoms. That's hept. And it's an alkane, nothing. I mean, there's no functional group, just branches. So it's an heptane. There's a methyl branch. Remember, this is your main chain now. Most things are attached to this. So you got a methyl, you got a chloro, you got another chloro, and you got this is 2 carbon atoms, so that's an ethyl. You got another 2 carbon atom branch, that's another ethyl. So you've got plenty of branches. So I'm going to start naming them alphabetically. Start with chloro. I think chloro comes first. So that's dichloro because there are two of them. And the positions of the chloro are one is at the first one, the other one is at the last one. So it's 1, 7 dichloro. Then I've got my ethyl branches. There are two of them. So it's a diethyl. There are two of them. And one is at 3 and the other one is at 5. So it's going to be 3,5 diethyl. And then I've got a methyl on the fourth one. So that's 4 methyl, and it's a heptane molecule. You be clear? Is this clear?
Yes, sir, I
Yes,
have
sir.
a question.
Yes.
What if we have like double bonds on the main chain and another double bond with the ethyl group?
Acha, I mean, that's possible. That's what I'm saying. The nomenclature doesn't really work most of the time, especially if the molecule is very complicated. Okay, is that clear?
Yes.
Okay. The nomenclature only works as long as the rules are being followed. Okay? I mean, the molecule is not going to follow the rule. Like it's if it becomes really complicated, it's not. I mean, you can't use the nomenclature because the rules won't work. Okay. So you just have a limited set of rules, and as long as the molecule is following those rules, then you can name it systematically. Otherwise, you can't name it systematically. Then you have to give it some other name. Okay. I mean, a lot of times, most of the times, you just give them generic names. They're named after scientists. TK, they're not named. I mean, they don't have systematic names. The simple ones, they usually do have systematic names. So just remember, don't take naming that seriously because for complicated molecules, they won't work. The rules won't work. Only works up till a certain complexity, and that's it. So let's we're done with naming basically. Okay, so I'm going to start with isomers now. I think I've posted. I'm going to post this worksheet or naming worksheet. Try and do those questions. Just make sure go through them. At least you know what these functional groups are. At least you're able to identify if skeletal formulas, structural formulas. I mean, we'll keep doing this. Okay, all of organic chemistry will be doing that. We'll be doing naming over and over again. Every time we'll try and name molecules. But try and revise this. Okay, this is kind of important because you're not going to get a very direct question on this. But if you don't even know what the structure is, you wouldn't be able to solve the whole question. Okay, like if they give you a reaction with 3-methyl pentanol and you can't draw this, then you're pretty much you lose all the marks in organic because you weren't even able to figure out what the molecule is. So it's something that's basic, but something that's very important. Okay. So let's continue tomorrow then. Okay, everyone, take care.
Allah Hafiz.
Thank you, sir. Allah Hafiz.
Allah Hafiz.